Welcome back. In a way, digital conferences have something in common with the debates around climate change and sustainability. Only if everybody is on board can we actually have the discussion and then also action and then results. So welcome back, ladies and gentlemen. We think that our panel is all on board, and talking about which, in this case, we can actually extend the time beyond 6 o'clock. However, what we can't do is extend the time until it runs out of us reaching as a global community the 1.5 or the 2-degree goals. Now, ladies and gentlemen, we are here in Berlin. A couple of kilometers away there is a clock, a downward running clock, telling us that it's about 7 years and a month until we have exhausted our chance to still reach the 1.5-degree goal this century, and until we actually have done this turning point for the 2-degree goal, we would have something like 24 years left. Now, what we are talking about is another 6 years on top, the year 2050, and the question, can we really assure that there is climate-neutral aviation until then? It's a fantastic panel put together, and let me quickly refer to each and every one of them. Sandra Bour is the head of Airbus Demonstrator, and wonderful that you are with us. The executive director of the ILOT Polish Aviation Institute, Pawel Stężycki, is with us high in the direction of Poland, and thank you very much for nodding. From AvioAero company, the head of research and advanced technology, Luca, Bedon. Wonderful you're with us. Then the CEO of Skylife Engineering from Sevilla, María, Ángeles, Martín, Prats. Great that you're with us, madam. From the Cranfield University in the UK, the director of Aerospace, Professor Iain Gray. And from GKN Aerospace, the director of research and technology, Henrik Runnemalm. Last but not least, a gentleman that you should have already seen yesterday. It's the executive director of Clean Sky 2 joint undertaking, Axel Krein. He's been in that position since last year. The one very seldom European public-private partnership which is actually working and working on developing innovative cutting-edge technology to decrease CO2 gas and noise levels in the aviation industry. And yesterday you were really optimistic and said, yes we can actually achieve climate neutrality, carbon neutrality by 2050. So you take it away, and I'm looking forward to your absolutely fantastic panel.
Yeah, thanks a lot, Connie. Thanks for the introduction, and let's see whether the panel colleagues will share my optimism today. We'll see after the session today. You have to cope maybe with a bit of a weak tone because I'm participating with one device on the camera and with the other device on the phone, but hopefully the combination of both will work. So good afternoon to everyone, and a very warm welcome to this panel towards climate neutrality by 2050. As Connie said, we have a very prominent panel today, a very prominent cast, very diverse backgrounds and experience, representing a really excellent cross-section of European aeronautical experience and expertise, individually from their personal backgrounds, but as well from the entities they are representing here. So we have large industry, we have SME, we have research and technology organizations, as well as university representation. With regard to the agenda, so we have 3 topics planned for today. I will introduce very briefly with a brief overview of Clean Sky 2 and a bit of the challenges ahead of us. Then we will move into the main part of the discussion, 2 parts of it. The first 30 minutes roughly with 2 questions for each of the panelists. They have prepared a bit on that. I've asked them up front to think about the initial objectives for their engagement in Clean Sky 2 and the achievements up to today, and also provide an overview what are they going to do next. And the second part is then going to be an open Q&A, and we are very much looking forward to get your questions in order then I will hand over those to the panelists in order to get their answer. And at the end, again, I do hope that we'll get a better understanding whether those people share my optimism for climate neutrality by 2050. Let me go now into the presentation very quickly, Clean Sky 2. I think some of you, or potentially most of you, will know what it is about. If you go to the second slide, please. Yes. Here you see the environmental objectives of this joint undertaking, the public-private partnership, 20 to 30% reduction in CO2, NOx, and noise. This has been set at the outset of the program in 2014. When you then look at the next page, there you see the 33 so-called main demonstrators. You will see elements here from the propulsion side, the aerodynamic side, the structure side, the new configuration, the systems. So all the different parts of an aircraft, of a product, or in fact of different products, from rotorcraft to regional to business jet, and finally also to commercial aircraft. And we also have small aircraft in this program. Looking now at the participants, you see here that we have more than 900 different participants in the program now, and you see here a huge contribution from universities, more than 150 entities, more than 340 SMEs, more than 110 research organizations, and more than 300 larger industrial companies contributing to it. And I'm also quite proud to say that we are not just having the aviation and aeronautics stakeholders in there, but we attracted as well some automotive companies, some automotive SMEs engaging with us on this journey. Looking now at the region, and you see here the map of Europe and the so-called Memorandum of Understanding we have signed with 18 regions and member states of the European Union in order to benefit from the cooperation between us, the Clean Sky Joint Undertaking, the public-private partnership, and local initiatives in the different regions in order to pursue topics which are complementary to our program, to the Clean Sky 2 program. The next slide now. Looking now at what is next, respectively, what do we need to do next? You saw the environmental objectives, but it's also obvious that under the topics here on the right-hand side of the chart, the Paris 2015 agreement, European Green Deal for climate neutrality by 2050, including climate neutral aviation by 2050, we will not reach those objectives with the current plan, with the current Clean Sky 2 plan. I mean, we are well on track to achieve our objectives, but this is by far not enough to meet those objectives, those new objectives which have been recently formulated. The next slide, please, and there you see what is in the pipeline. You see on the left-hand side of the chart the so-called change drivers, which have been identified over the last months by the stakeholders, the aeronautical stakeholders, in order to achieve climate-neutral aviation by 2050. And this is the dotted line, the light dotted line, which you can see on the left-hand side of the page. And in terms of change drivers, 3 big change drivers have been identified. The first one, reduction of aircraft fuel burn, which is obviously then also reducing CO2 emissions. And this is calculated as to be up to 50%. So half of the problem can be tackled via this reduction of aircraft fuel burn. 10% can come from optimized air traffic management and operations. And 40% needs to come from new fuels. Those new fuels can also include, obviously, hydrogen as a non-drop-in fuel. So those change drivers have been identified, and on the right-hand side, you see the focus areas which have been identified, which need to be worked on. Firstly, hybrid electric and full electric architectures, and not just for smaller aircraft, for general aviation aircraft, but as well for regional and commercial aircraft. Second, disruptive technologies to enable hydrogen-powered aircraft. This could be a fuel cell application to produce propulsive energy on board of an aircraft, but this could be as well then the direct burn of hydrogen in gas turbines. And last but not least, the ultra-efficient aircraft architectures. Here the focus on radically new aerodynamics structures, systems, and new aircraft configurations. I'd like to highlight one point which you see on the upper part of the slide on the left-hand side. They have indicated the entry into service of those new aircraft. And I think that's very important that we calculate it backwards. 2050 climate neutrality, which means that we need to enter new products into the market latest around the 2035 timeline in order to really take the older and less environmentally fair aircraft out of the market before 2050. So it doesn't make a difference if we bring a new product into the market in 2050. So those new products need to come much, much earlier. And that's why I have put this window of opportunity, this technology development window in there in this decade. So we need to come to the technology development, the technology maturation, and the technology demonstration before the end of this decade, so between 27, 28, and 29. And that's exactly also the timeline when the authorization to offer of the new products which want to enter into the market by 2035 need to be offered to the airline customer or to whatever customers we are speaking about here. The last page, and speaking about money now, because that vision of climate neutrality by 2050 needs to be paid for. That needs to be affordable. And I've put here three big milestones and three big blocks of budgets. The first one, the research and innovation budget between 2020 and 2030, this next decade I was speaking about, roughly 12 billion euros of overall budget requirement, meaning funding and financial contribution from all the contributors at European level, at member state level, but as well at 100% funding level from industrial companies, for example. So the overall cost has been estimated to be in the ballpark of 12 billion. These 12 billion will then trigger the product development within the industrial companies coming from the OEMs to the tier 1s, tier 2s, tier 3s, and up to the lower tiers, up to the SMEs. And they need to spend then 50 billion euros in order to develop those aircraft. And finally, and lastly, the product deployment, the airlines or the customers of those products need to pay for that. And that's another 5,000 billion. So with 12 billion, we trigger the 50 billion, and that will trigger the 5,000 billion to be spent. I think we'll hear more about that from the panelists in a second. I just wanted to highlight those principles a bit to you so that our audience is well aware about those overall implications. And now I'd like to hand over to our first panelist, being Sandra. Sandra from Airbus is going to answer two questions. I've asked all of the panelists to come up with the answers to two questions. Firstly, what were the initial objectives on Clean Sky 2, and how many of those initial objectives did you achieve? And secondly, what is coming up next? So please, Sandra, if you may want to start, please.
Thank you very much, Axel. It was great pleasure. I'm delighted to be able to join you this afternoon and just as excited to provide that update on Airbus key Clean Sky 2 projects. Well, we all know aviation is experiencing its worst crisis in history. Concretely, worldwide domestic flight. Can you hear me now? Sorry. Can you hear me? Okay, thank you. So thank you very much, Axel. Of course, I'm very happy to be here with you this afternoon and just as excited to provide an update on some of Airbus key Clean Sky 2 projects. Well, we all know it. Aviation is experiencing its worst crisis in history as we speak today. Concretely, worldwide domestic flights were down 70% from months before a noticeable improvement in October. However, here in Europe, the second wave of COVID virus is being felt, still impacting our largest regional airports with 80% fewer flights. And incidentally, the ripple effect created by this slump in air traffic is severely impacting the global economy. And of course, we take a moment to think of those people who are still being affected by the virus today, both on personal and professional levels. It has indeed challenged our lives as well as the way we work. However, it doesn't change the fact that aviation ultimately brings people and nations together and must continue to do so. Aviation crosses borders and unites. And it certainly doesn't change the fact that even before March 2020, aviation was being challenged to answer a societal call for ecological change. This means we shall continue working beyond the health crisis to answer those calls for solidarity, as well as supporting local and international economies. So Airbus research and technology programs are critical to support these ambitions. And our Clean Sky 2 projects are great examples of this engagement and were launched in the frame of this initiative because Europe was the right environment. All our projects have added value across the board and continue to do so. If I refer to projects, I would think of ultra-advanced engine concepts such as UltraFan and the specific technologies to integrate these engines to the aircraft. Next generation fuselage optimization was also part of Clean Sky 2, reducing aircraft weight and operating costs. And projects like Blade as a natural laminar flow flight demonstrator pushed the TRL maturity. And despite local confinement constraints since March this year, these transnational projects have progressed, and we are proud of the resilience our teams have shown. In order to build on these technology bricks, we are scaling up our projects for the next round. We will be driving topics like the disruptive cockpit to focus on autonomy and to increase pilot awareness and safety. We will continue projects enabling a strong industrial ramp-up, like the ongoing integrated multifunctional fuselage demonstrator for high-rate automated production. This is what was already part in Clean Sky 2, and if we focus on the future, we are preparing the path towards most efficient and world's first zero-emission commercial aircraft. As you probably know, and maybe you can see it on the slide, in September, Airbus revealed 3 concepts representing different approaches to achieving zero-emission flight by 2035, exploring various technology pathways and aerodynamic configurations. But getting to that point of maturity within 10 years, as you mentioned, Axel, will be possible only through initiatives like programs supported with Clean Sky. And Clean Aviation is the ongoing project from Clean Sky 2, which needs to continue as an essential to cross-collaboration of nations, regulatory bodies, and industrial ecosystems. In the frame of Clean Aviation, our effort will focus on technologies embodied by our concept aircraft. 3 of them are really essential: disruptive hydrogen technology, short and medium-range aircraft design and manufacture improvements, and integrating technology breaks for hybrid electrical aircraft. Of course, we count on our long-standing partners to join us in these endeavors. And EU support is required to foster technology development for hybrid propulsion systems and encourage massive scale-up of renewable energy and hydrogen. Currently, we are aligning to answer the European Commission call for the expression of ideas to propose and detail content for the Clean Aviation Programme. To wrap it up, so much has been already achieved since the Clean Sky undertaking began in 2008. Going forward, we are going to rely on the Clean Aviation Partnership even more. A lot really remains to be done to achieve the goals you have so well described, with ultra-advanced aircrafts, airframes, engines, and hydrogen has emerged as a potential game changer. With the call for ideas now on the way, a strong response from the ecosystem will help Europe recognize the great effort required still to evaluate the new technologies. European-wide research and innovation initiatives remain complementary to national initiatives and facilitate integrating the entire European supply chain and ecosystem. The approach to include EASA upstream in the development progress to accompany certification of aviation's future technologies will increase reactivity and ensure standardization across initiatives. In short, this will be an exciting time to fly. Thank you very much.
Thanks a lot, Sandra, for your enthusiastic description of what you have achieved and what is going to be on the horizon. I'd like to directly hand over now to Pawel to continue with his experience. Pawel, please.
Okay, so hello everybody. Thank you, Axel, for this introduction. So our research institute, same as entire area organization, is the organization that makes the knowledge triangle complete. I mean, universities work on fundamentals and fundamental research at low-level TRLs. Our institutes, like area organization, take up and develops these results towards higher TRL levels, delivering technology that can become final product by TRL 7-9. So AREA and its members, like our institute, are therefore cooperating with universities and industries, closing the gap in between. We bring to Europe unique experimental facilities and groups of experts reaching a critical mass in many disciplines. This includes work on airframe design, so we have some experience with Airbus, of course, better engines and new fuels, as well as more efficient air traffic management. We have a long track record of European cooperation amongst each other and together with industry in order to reach European goals. I mean here Vision 2020 or Fly Past 2050. Therefore, AREA members, I mean European research institutes, are well-known partners in EU framework programs as well as in JTI's Clean Sky or CESAR. Our resume of important projects and contributions contains configuration studies assessing disruptive architectures such as distributed propulsion, joint wing, tilt rotor, etc. But also trade studies for empennage configurations such as BLI, new tail configuration with a V shape instead of T shape, and so on and so forth. We also play a key role, I would like to believe we play an important role in commuter aircraft concepts, including advanced manufacturing and integration technologies. And these two programs, SAP and AIR, are great examples here. In big, I mean, commercial aviation, the technological progress is huge since impressive amount of money were invested there. Now, the application of these technologies to BGA or commuter aircrafts creates a big chance for development of this segment. Additionally, the idea seems to make more sense nowadays than before, since COVID-19 may reduce mass travels, hopefully not. But if it does, we may expect smaller airships will transfer people to their final destinations, not to hubs. Such technologies are, for instance, single cabin with more autonomy, mentioned here before, which was developed in COST program, new manufacturing technologies to reduce cost and weight that make the structures or planes greener, where SAT program is a great example here, and we can see two examples of SAT program demonstrators. If we go to the next slide, please. What is coming next? Well, today it's difficult to say what the future will look like, So research institutes connected in area started to work on the area vision on the future of aviation document. So we work on possible scenarios, and so far we identified 4. Extreme one called MANMAX, when a world is characterized by deglobalization and fragmentation, extreme nationalism and populism, and aviation could be an expensive luxurious and highly desirable product, but is unreliable due to the climate change and the different sources of instability. There are few industrial partners or players in this scenario with no innovation and limited R&D needs. Next scenario we called Tech for You, when a world is characterized by multipolarity and competition, where high cost of research and development with national and short-term focus is a kind of limitation. And then mobility is flexible with air transport as a part of the local transport system. The overall approach is to strive for door-to-door mobility. The stripping down one shows the world as, well, the world is characterized by political stability, centralized governments, slow but stable economic growth, and then a limited and highly controlled mobility due to the high prices, security threats, but also flight shaming and regulation. Few industrial partners, due to high cost and low demand for flights, have limited ability to grow. And then my favorite one, optimizing together, when a world is characterized by unification and harmony, global cooperation and collaboration, market-driven economies, something we could live for a while, if you can still remember that. Then mobility is growing and is fully sustainable. Different aviation solutions are available for all genre segments, from UAM through even formation of flying to suborbital flights in 2050, who knows? What is common in all these scenarios is that we will move towards a more comprehensive transport system. We also expect an increased public awareness and demand even for security and safety of this system, as it was mentioned before as well. In order to achieve climate neutrality, have a healthy research and innovation ecosystem, and to realize a sustainable future for aviation, the degree to which we are all able to lie behind a common goal. A common goal is absolutely essential. Thus, cooperation between governments, society, industry, research, and education is a must. And our, research institute's role is to moderate it and fill the gaps if identified. So to answer your question, Axel, I'm optimistic about reaching our goal, but it needs to be the goal of everybody, absolutely everybody, politicians, industrial partners, researchers, and scientists. That's why we support European initiative helping aviation technology to move forward. Thank you very much.
Thank you, Pawel, for the view about how area sees the world. But let's go now over directly to Luca. Luca from the Aviation. Luca, Bedon, please.
Hi, good afternoon, everyone, and thanks, Axel. Thanks for having me and joining this panel to talk about such a critical topic like make aviation sustainable. First of all, Clean Skies is a unique opportunity we are exploiting to explore and distill the right technology, the engine technology, architecture, which are needed to meet the 2050 sustainable target. So I will provide you a quick overview of what we are doing already and what we are thinking is the next step. Our involvement in the program is very, very broad. We are investing in technology in all the segments that Axel was introducing at the beginning, from mechanical transmission for advanced rotorcraft, innovative turboprop engine, architectural study for regional power plant, up to technologies for turbines and gearbox modules, which are critical elements of all the future large engine application. The beauty of the program for us is that all these initiatives are really interconnected. that what you are learning from one program is really applicable across all the others. And I will better explain this concept through two clear examples we can describe here. So this chart summarizes two programs we are developing in Clean Sky 2. So let's start from the bottom part of the chart, which is describing what is the Maestro program, which is a program where we are developing technology like additive, advanced cooling, and next generation compressor for small turboprop engine in the SAT or BGI class. The beauty of working on a small engine like this one is that the validation lead time and the associated costs are significantly lower and reduced. In fact, we follow a very fast approach to achieve the right technology readiness level just in time to allow their implementation in an actual product. And what you can see in the chart is the real handover between the research and the actual product development, since all the great technology is already implemented in the Catalyst turboprop engine. The Catalyst is the new generation of turboprop, completely developed in Europe, completely based European technology, which will deliver up to 20% emission reduction over the state of the art. So I can start to answer Axel's question now. So yes, we can do it, and we already proved it. And the beauty is that we can scale up this improvement at bigger scale, and also move forward in the same segment to the next step, which means hybridization and electrification. The second topic I would like to cover today is about the inducted or the open rotor architecture, which is in the upper part of this chart. This configuration was already part of the first Clean Sky program, where together with Safran, we demonstrated the potential of this solution. And we will keep working on that in Clean Sky 2 very intensively. In Clean Sky 2, we made significant effort to further advance the solution to identify the optimum configuration we would like to bring into the market soon. So we depart from the original control technique architecture, the one you can see on the left part of the chart, to what we are envisioning as the optimum and best performance configuration, what we call USF, unducted single fan. We proved their validity through several tests, including a collaboration with Leonardo in the Iron program, where we tested and we assessed integration impact. But more than that, we were able to tackle one of the biggest challenges that this architecture always faced. So we proved the possibility to reduce the noise level to an acceptable limit. Thanks to the acoustic technology mature and validated with our partner in Airbus, the open rotor architecture is now on track to deliver up to 25% fewer emission versus the current generation of engine, which is the second part of my answer to Axel. So what's next? So the next is, you can go to the next page, please. The next phase is really to think about the demonstration. So research is almost finished, I would say. So it's now time to demonstrate. We have the largest and depth technology portfolio ever, and we need to leverage it to prepare the next generation of product, focusing on the short and medium range and the regional segment, which are by far the biggest contributor on the commercial aviation emission. So the three recently published provide a strong focus to everyone, and we need to prioritize what is important for the business. The incoming innovation program will be important to consolidate all the technology investment we did so far in the open rotor architecture and to complete its demonstration at product level to be ready for the 2035 entry into service. The other fundamental objective will be to mature the hybrid propulsion at system level to enable implementation of this technology in a regional aircraft product, since it's clear the segment that we will see this improvement becoming real first. With that, I will turn over to Axel for the next.
Thanks a lot, Luca, specifically also for your optimism that you also confirm that it's doable. The question is, how can we organize ourselves all together in order to align forces in order to make it finally happen? Now over to María. María is representing Skylife, a very interesting SME concept from Spain. So María, please, what is your view on the topic?
Hello, Axel. Can you hear me?
Yes, I hear you well.
Hello, can you hear me?
Yeah,
Yes?
I can hear you well. Perfect.
Okay. So, good afternoon. Thank you very much for introduction. I have technical problems, so I will start with the first question. Skylife is working currently on more electrical aircraft and digitalization since 2011. During these 10 years, we have developed technologies capable of flying. Our goal is to be able to be a reference in onboard power conversion. The systems developed have been the results of successful Clean Sky 2 projects, in which we have reached a level of TRL 5 and 6, complying with the aeronautical regulations to fly. We have proposed to coordinate actions with the industry and the AJU so that these systems can be qualified and validated in the Clean Sky 2 demonstrators. In this way, our primary objective is absolutely aligned with those of Clean Sky 2. We want our systems to reach fly and are useful for the aeronautical industry in the context of more electrical aircraft and all electrical aircraft. In this pandemic that we are experiencing, the duration and nature of Clean Sky 2 projects generate job stability, tranquility, and confidence, maintaining the know-how of employees. We currently have 30 employees, and we expect to grow in next year because the expectations for 2021 are good. Next slide, please. So currently, we are participating in 9 Clean Sky 2 projects, and we are coordinating 6 of them. The topics of these projects are related to digitalization of factories, for example, Aries and Dileco. Also electromechanical actuators, like MR for Flight, Valema, and Amulet. Electrical power conversion, like Hypodis, Hypnotic, and Decade. And cognitive computing in the cockpit, Harvis. All of these projects are in line with the objectives of the European Green Deal, in particular by enabling key technologies both for decarbonization, reduction of noise, and efficient use of resources. The TRLs that we will achieve in projects such as MR for Flight and Hypodis is quite remarkable. The results of these projects will be pieces of equipment that are planned to be tested on the Flight Test Bed 2 and Advanced C295 from Airbus Defence and Space. Thanks to the involvement of Clean Sky 2, a great outcome of Clean Sky is the cooperation between organizations in different European countries, fostering the collaboration and research of shared know-how across Europe. This collaboration allows the sharing of knowledge between European actors and brings more business opportunities than a company could achieve alone. In our experience, the time it takes to raise a low tier L2 and aerospace-ready product is approximately 10-15 years, where Clean Sky supports both low TRL through thematic topics and medium TRL through calls for proposals. However, there is still risk for SME, because after this long period, and it's just when the Clean Sky project ends, and it's necessary to raise the TRL of the technology, there is a financial gap that is still unsolved, and that needs to be supported by other financial means. Normally, SMEs often have limited access to other financial resources, such as bank loans. Pre-financing is a key enabler for small businesses to participate in European projects. This is the main financial advantage that European projects have compared to national and regional projects, at least in Spain. In addition to this, the presentation of proposals and the bureaucratic and administrative aspects should be standardized in Europe in order to align and complement European aids with regional and national ones. About the next steps needed, we should keep the ecosystem intact in a New Horizon Europe partnership. We shouldn't change what is working well, so we should ensure the instruments and conditions allow this. Finally, I would like to propose concrete actions for young people to sponsor talent management and capacity development through scholarships, competitions, and training courses that complement their technical training. We must try to bring young engineers closer to the real needs of the market, and we must train soft skills, project manager, basic financial knowledge, and emotional intelligence as well. While Skylife's presence, activity, results, and commitment to Clean Sky 2 is remarkable. Thanks to Clean Sky 2, we are creating highly qualified employment, generating a profile of great interest to the industry, and maintaining the intellectual property that allow us to explore other business opportunities in other sectors such as naval, defense, health, or energy. That's all. Thank you very much for your attention.
Thanks a lot, María. Thanks a lot for your elaborations on the topic, and I think it's a very, very good example on how an SME can contribute to the overall objectives of a public-private partnership like Clean Sky. And I think it's also a good way of looking at things we can improve, and you highlighted a few of those. But I'm very glad that you are advocating as well for keeping what is running well, and I think we need to build on that. But we'll come to that in a second. I'd like to hand over now to Iain Gray from Cranfield University, who will give us a perspective, another perspective from a university perspective, that also maybe can touch upon a bit on how it is to be a UK entity and contribute to Clean Sky.
Okay, thank you very much, Axel. Can we share the slides? Thank you very much. So Cranfield holds a unique position in the university landscape. We have our own airport, our own runway, we have our own aircraft, our own pilots, our own air navigation service provider, and our own fuel farm. And that gives us a unique opportunity to do research, to test, to develop, and to demonstrate and validate low-carbon solutions. And over the last few years, we've invested well over £100 million in new facilities under what we call the umbrella of the Cranfield Global Research Airport. We're very proud as well, just a few weeks ago, that the Californian startup company that moved across to Cranfield about 12, 18 months ago flew the very first hydrogen fuel cell aircraft from Cranfield. So in terms of Clean Sky 2, Cranfield very much values the relationship we've had across Europe with both academia and with business. And we've been involved in the Clean Sky programs for well over 12 years. Pleased to be involved in some of the bigger programs, the configuration programs we've heard about, the propulsion programs, some of the manufacturing programs. But we should always remember as well that in the strive to be zero carbon, it's not just about the product itself, it's the through life cycle. And we've been very pleased to have been involved in some through life management programs, some early manufacturing programs, particularly pleased to have been involved in the technology evaluation side of Clean Sky 2. I pick on just two programs that I'd refer to. One is a program called Hermes, which is looking at through life maintenance concepts. We've been working with airlines such as TAP. In fact, we had a demonstration in Portugal. But it's important to realise that from a zero carbon point of view, we need to focus on the through life issues. A small niche project, and where the universities can play a very strong role as well, is on some of the niche projects. A kind of project called Efficient there, which is looking at environmentally friendly fire suppression systems, looking at what happens when halon goes obsolete, a program we were working with Airbus on. It's also important to see the links between the Clean Sky 2 program and some of the other Horizon 2020 programs. We've had strong involvement in CESAR, the joint undertaking there. To achieve zero carbon, we need to see those connections. And hydrogen, Sandra referred to hydrogen as a game changer, and Cranfield sees that very much to be the case. And we've been involved in a Horizon 2020 Enable H2 hydrogen project. And we do see hydrogen as being absolutely key to achieving the goals moving forward. Next slide, please. So just a few words about how I see the future. I'm not a politician. I'm not going to get into the UK position regarding Brexit. I'm a European. I've been involved in European collaboration my whole career, whether it be with academia, whether it be with industry. And I strongly believe in the European model from an aviation point of view. And just to be absolutely clear, Cranfield very much wants to be part of the future clean aviation initiatives. We'll find ways to make sure that happens. But I thought I'd just give you a quick insight into some of the initiatives that are happening in the UK. The Aerospace Technology Institute, which funds industry and academia at £150 million a year. It launched its Accelerating Ambition strategy last year, and sustainability is a core part of that agenda. Things like the Jet Zero Council, which is a government-sponsored initiative, 2 Secretary of States, Department for Transport and Department for Business, looking at zero carbon solutions, with a particular focus in the first instance around sustainable aviation fuels. Things like the Fly Zero project, looking at how we can develop ideas, technology concepts and ideas for a zero carbon transatlantic aircraft by 2030, 35. Initiatives such as the Future Flight Challenge, which is looking at the aviation ecosystem. So it's not just looking at the products, but how these new products will fit into the overall ecosystem. So there's a lot of different initiatives going on around the UK to support the zero carbon agenda. In terms of your optimism, Axel, I share your optimism, but I caution against the fact that there is not a silver bullet. There's not one single solution for this. In fact, there will be different solutions for different segments of the market. And the new aviation economy, the urban air mobility, small aircraft may well see battery electric, hydrogen fuel cell. I think that's very feasible within a relatively short period of time. The real thing that we need to win is on the 100, 150-seater market. I think that is possible, and I think hydrogen is a potential game changer solution there. And then on the ultra long range aircraft, that may require a different solution. Again, it may require sustainable aviation fuels, but complemented by changes in market behaviors and things like that. So yes, I'm optimistic that there's not one silver bullet.
Thanks a lot, Iain, and thanks for your explanations related to what Cranfield is doing currently, has been doing in the past, and also what you intend to do tomorrow, and specifically also for the indication of what the UK is doing overall, because I think that's an important topic in these during these times. I mean, let's see what's going to happen on the political side, and then we'll see how we can manage this cooperation in the future. So let's go now to the last panelist before we go to the generic questions which have been indicated by the audience to us. Henrik, please indicate your perspective from a GKN perspective, and you are joining us from very north of Sweden, so you have been in the dark already for 1.5 or 2 hours even.
Well, thank you, Axel, and I'm happy to give you a little bit of a flavor of what we have set out to do in Clean Sky 2, and a little bit of our view on moving forward. So on the screen, you can see some of the activities we are working on right now. And from the engine perspective of GKN Aerospace, it's a lot of activities in relation to improve the efficiency of our propulsion system. Before I go into the details, I should of course mention also that GKN is also active in collaboration with, for instance, Airbus on the advanced multifunctional fuselage solutions and introducing new concepts in that area as well. But looking at the propulsion system, we think that there is quite still some contribution to be made on these systems, and bringing the solution to the market through collaboration is the key, and working together, which is definitely demonstrated throughout the Clean Sky programs. So as you can see, ultra high bypass ratio engine is a key factor on driving the efficiency of future engines. We are partner in the UltraFan demonstrators, where we look at developing new advanced structure and increased functionality of those structures, so embedding new type of technologies in the structures still needed there. And as the engine grows larger, we know that we need to carry more weight with us if we don't do new investments there. We are also looking quite heavily on how to do the engine much more compact. And this is done through advanced aggressive duct solutions, but also on kind of being able to pack the engine in a more efficient way. This is done together with our partner Safran, and we are really interested to see how we bring the demonstrator now to the higher TRL levels, and I'll give you some flavors on what that is. And then we all know about the geared solutions that is out there. We see that this type of engine configuration will still have a good way to go. The first generation of engines is introduced on the market, and definitely there is more to take from that concept. Having said that, we also understand that independently on what type of fuel solution we are bringing, the improvement of efficiency will be necessary to what we can bring in collaboration with our partners. So on the right-hand side, you can see some of the ongoing experiments and maturation activities that we have right now. We are doing full-scale testing of new functionality and advanced two-spool concepts. We are validating methods and technologies that prove both higher efficiency in the propulsor, but also thermal capability of our systems. And together with that, of course, it's critical that we support all development in parallel with manufacturing technology, so that we really are ready and set to bring this technology to the market when it's ready, at rate, of course. So looking beyond Clean Sky 2, we definitely see that hybridization of our propulsion system is definitely one interesting alternative. We also see that novel architecture, and having been part of the open rotor concept that was run through the Clean Sky 1 activity and has been continued into Clean Sky 2, we definitely see that that is a novel engine configuration that has a lot of potential meeting the overall objectives. So, but at the end of the day, it's only possible to achieve this through collaboration, and we really see that the Clean Sky initiative have been the vehicle for creating this collaboration. So by that, thank you, Axel, and I hand off it back to you.
Thanks a lot, Henrik. Thanks for your perspective from GKN, but also from your personal perspective. We have now heard quite a lot about the different technologies with regard to Clean Sky 2 and achieving the objectives in Clean Sky 2 in that program, and also some perspectives about the future. We have received a couple of questions related to how can we continue, we as the aeronautical sector, how we can continue to attract young engineers and scientists to aviation and to aeronautics. And I think that's a question probably which is in the core, it should be in the core of our thinking for the future. I've been indicating at the beginning that we have 5,000 scientists and engineers working in Clean Sky right now, not all young anymore, but we need to obviously secure the future of those 5,000 people, meaning when people are going into retirement, that we have opportunities for younger engineers, but those need to be willing to join us. And maybe I'd like to ask some of you at least to give us a perspective on how do you see that? What are you doing very concretely in your area of responsibility? Maybe we start with Sandra, because you are a worldwide operating entity, and maybe you can also indicate maybe potentially some differences between the different countries or maybe even continents on that topic. Sandra, please.
Well, thank you, Axel. I think one important thing is really we stand in front of a new revolution of aerospace, and it's the most exciting moment you could imagine to join this sector. So if you look at the scope of aerospace as it stands today and the future of flight tomorrow, with everything that has been said by all the panelists, there is a wealth of opportunity in joining that sector. And it goes really beyond the classical aeronautical skills that this industry would have looked for in the past decade. We have growing needs for artificial intelligence, for data, image processing, new materials application, continued renewal also of core skills. And all of that, I think, is really a great ingredient to attract the youngest generation. So we have indeed across the different nations several programs to engage students at all levels of their learning curve and have apprenticeships, graduate and postgraduate studies where we encourage learning while earning. So all of that clearly exists, but beyond those schemes, which we know, my message is really, I think it's the greatest time to join the aerospace industry. And I would really encourage all the young ones there to look into that sector and discover all the great things we can do to really achieve this very ambitious goal to decarbonize the industry.
Thank you, Sandra. Maybe over to Pawel to provide a view about how does AvioAero see that, because you are covering the whole of Europe. Do you see differences among the different countries and the different associations, the different entities participating and contributing to AvioAero?
Young people are pretty much the same all over the Europe. It's a good news because they are ambitious. They are hungry to work on something new, advanced. So what we are trying to do, we are trying to attract them with new technology, the vision that is going to happen in not tomorrow or the day after tomorrow, but let's say in 2050. To attract new people, we need to show them the high-level goal, like supersonic flights, like suborbital flights. They are not pretty much interested in tuning the technology by 2% each year because they are too ambitious and they want to have impact, and they want to have impact now. What we are doing across all countries, we are trying to cooperate with universities. We invite young researchers, young engineers to our laboratories. We are trying to engage them in our real programs because they do not want just to practice. They don't want to learn, and they would like to have an impact. This is what we are trying to give them.
Thanks, Pawel. I think that's a very interesting perspective because that's also something we are doing in Clean Sky, obviously, in connecting the different dots from very upstream research to this applied research up to the demonstrators and then to the more downstream research. I think that's exactly an environment we are providing here, and we are seeing that among the panelists around the table coming from the different areas and representing the different areas. And I'm glad that you see there is demand basically from the student side in order to join that community and that industry. Maybe looking at the topic, maybe a third and last one on that topic, María, maybe you can give us a perspective because you are a professor in Seville. And how do you see that at the uni in Sevilla? Is there enough demand? Are there enough students coming and interested in that industry, or they're all attracted by the Teslas of this world? María, did you get my point? No, maybe María can't hear me right now. Maybe then over to Iain, another university, Cranfield. How is it there? Tesla more attractive than GKN, GE, Airbus?
I think Tesla is a great example of where a new economy can attract students. But you have to look at aerospace as a new aviation economy, look at space as a new space economy. The opportunities for students to form self-form groups and build their own drones, fly their own drones, to build small electric aircraft. There's a huge opportunity for practice-based learning about some of these new technologies. It's so exciting. If I look back at my career, Axel, I would say fundamentally, I've been part of implementing somebody else's strategy maybe 40 years ago. We are now on the cusp of a new technology revolution where we're setting the agenda for the next 40 years. And it's such an exciting time to be part of the sector. So I see huge energy and excitement in our students. I see a new kind of environment. The Teslas of the aviation world are out there. But you also have the big, well-established businesses, the Airbuses, the Safrans, Thales, Rolls-Royces of this world, delivering some really exciting technology. It's incumbent on us all to portray that excitement to people in schools and things, to attract people in. But the excitement is there.
Thanks, Iain, and thanks to all of you. Next question is around the topic of short range versus long range. We have been speaking about hydrogen, we have been speaking about more electric, full electric, and I'd like to hand over that question to you, and maybe starting with Luca and Henrik. Differences related to technologies and potential entry into service dates. Sandra has given us some indications at the beginning, but how does it look like from an engine perspective? How do you see the world as an engine OEM there in terms of short range versus long range? What do you see there in terms of different technologies and entry into service dates of the products? Luca, do you want to start? Can you please unmute?
Can you hear me now?
Yes, hear you now. Okay,
good, thank you. So first of all, we should just remind one thing we didn't mention today because it's clearly for granted, but we need to keep in mind that technology need to have safety in mind first. We need to keep maturing technology at the right pace, but still meeting the level of safety we achieved in the last 40 and even more years of evolution. So with that in mind, as an engine maker, we need to push, as we said multiple times today, on even greater propulsive efficiency, thermal efficiency, and we will do that through disruptive architecture. Open rotor, smaller core are clear evidences of what you are targeting, and developing more capable and lighter material as we did always in the past. We take the challenge of the hydrogen seriously. We think that's part of the equation. We recognize that could be a game changer, but that's where we need to combine all the effort together because there are multiple aspects on the hydrogen challenge we need to consider. From an engine maker perspective, we see that possible. We need to recognize the challenge in adapting our turbo machine to the hydrogen. But it's a great example of the collaboration, because today is more a matter of production capacity and capability and distribution, infrastructure. So we need to look at the problem in a holistic way. So in the short answer to your question is yes, we have multiple ways to tackle the problem. In the short term, there are incremental technology and disruptive technology in the architecture of the engine. And in the longer scale, game changer like hydrogen could be a key element of the solution.
Thank you, Luca. Henrik, how do you see that?
I agree with what Luca say here, but I would also like to add that I think that as a propulsion provider, we need also to make sure that we have technology ready to a maturity level and to contribute to the total reduction to a certain level. And we usually talk about that we need to provide double-digit numbers in CO2 or emission reduction in order to have an offer that could really be brought to the market. And we believe that the timing of a clean aviation continuation program can bring that to a maturity level at 2025, ready to implement into a new product on the market. And then in parallel to that, we need to drive the next generation of introduction and mature that so that we are ready with the ambitious target that we have in Clean Sky and meeting the overall objectives of this program. So double-digit numbers for emission reduction is necessary at each introduction point onto the market.
Thank you, Henrik. You indicated that if we want to get to climate neutrality by 2050, we can't work only on evolutionary technologies. We need to work on double-digit and I would say higher double-digit numbers, not lower double-digit numbers, in order to make it. But obviously, those high gains are coming with higher risks. And I'd like to check out with you, and this was one of the questions coming in, how do we deal with those potentially higher risks in this context? And can a closer cooperation with EASA in this context, can that help? And if yes, how? María, can you hear us? What is your view on the topic as an SME? No, I think María still has difficulties to listen. And maybe she can try. I will write you maybe something via the chat, and maybe again you have it. So maybe over to Sandra then. This higher gain, higher risk topic, and the role of EASA. Maybe you can comment on that. You are still muted, Sandra.
Can you hear me?
Yes, thank you.
Okay. I said several of the panelists have mentioned the track record we have in the aviation industry on safety, and that clearly cannot be compromised. So whatever we will come up with in the future, and we mentioned it, hydrogen has a huge potential, for example, it will not be put into service if it does not meet the standards, the safety standards of today. And therefore, the collaboration with EASA and all regulatory bodies is very important, because it's about new technology, new handlings, new ways of writing down the regulatory requests to make sure that we do get to that very same level of safety as we know it of today. And therefore, it's crucial to embark them right from the beginning to make sure that it is really a collaboration, a mutual understanding on how is the technology progressing and how do regulators address it to make sure we stay at the safety level we have today. And I said that we are very much looking forward to have EASA embarked in this clean aviation project, because it's really about collaboration, not only across industry, but also with our regulatory bodies.
Thank you, Sandra. Yes, hear you now well, María. Yes, I can hear you now.
Oh, thank you.
Did you hear my question?
Finally. Yes, it was about EASA? About EASA?
Yes, exactly. It was about the higher gains are coming with higher risks, and then the involvement of EASA in that risk mitigation. If you can please give us your opinion on that.
Yes, thank you. Thank you very much. Yes, in my opinion, of course, a greater collaboration in technological development since the beginning would be very interesting to make the onboard equipment qualification process more flexible and streamlined. Yes, of course. That's my opinion.
Thank you. Thank you, María. I have now a question, which is a more technical question. There were a couple of points around the importance of materials. There was a point on 3D printing, more general about new materials in this context. Who would like to take that question? Who is in a position to comment on the importance of new materials for the future double-digit gains?
I'm happy to give my input, Axel.
Please, Iain.
So, I mean, it's interesting when we talk about new materials. Carbon fiber composites is often talked about as a new material, and yet most of us around this table will recognize composites is well over 50 years old. It takes a long time sometimes for materials to work their way through the maturity chain. But we are seeing, huge increases in efforts regarding how we use materials, new design optimization methodologies. We're seeing new materials like graphene coming along that can make quite a big difference in terms of lightweighting and their electrical properties. In terms of 3D printing, again, 3D printing is becoming a different market for different applications. You have the more cosmetic side of 3D printing, which is appealing to the architecture, the design side of it. There's powder printing, and there's now the 3D printing on big heavy parts, big aluminium and titanium parts. We're seeing them being used in other sectors. The aerospace sector is obviously got to satisfy itself of all the safety risks. But it's happening, and it takes new products to allow us to implement new things. It's quite difficult to retrospectively introduce some of these new materials and 3D printing into existing products. But for new products, we need to think about it quite differently from the beginning. The new materials are there.
Yeah, thanks. Yeah, please, Luca.
Yeah, so just connecting what has been said by Iain, 3D printing or additive can provide a strong benefit if you start to design a new product having that technology in mind. And I can bring you two actual examples, again, of application of this technology. We develop a new material thanks to the additive 3D printing, and we print LPT blades, which are now under certification, actually already certified in service on the UpNext program. And thanks to the technology, which is also becoming a new material to some extent, we deliver something like hundreds of weight saving for the product. Even more, the catalyst application I was describing in my presentation has been designed since the beginning, having the additive in mind. So just leveraging that design for additive or 3D printing attitude, we remove hundreds of parts from the engine, replacing with just 11 components. So those are simple example, but a result of more than 15 years investment we did in the technology, because we recognize that there is a lot of hype around additive, but the level of maturity you need to achieve to bring a benefit in the product is very high. But once you start to design a product since the beginning, having the additive in mind, the benefits are there.
Thank you, Luca. Henrik, something to add?
Yeah, Axel, can I please add that there is also another aspect of 3D printing that we should mention, and that is actually the resources of material that we are using as producer of advanced components is also the opportunity to use 3D printing to reduce the amount of material that is actually spent during our processing. And we have shown and also implemented a number of products that uses more direct laser deposition technique in complementary to what Luca mentioned on the powder bed 3D printing. And we definitely see that as an opportunity going forward as well.
Thank you. I have a question here for Sandra, which is related to the competition between the gas turbine and the electrical motor. Up to now, or at least the last decades, it was always the gas turbine providing the propulsive energy for commercial aircraft. And now it seems to be that the electrical motors may step in, being potentially powered by a gas turbine or by a fuel cell. There are other opportunities. How do you see that competition between gas turbine and electrical motors?
Well, I'm not sure we should talk about competition. I think we have different products, and I think Iain mentioned it at the beginning. There is not one single solution. Can you hear me?
Yes, hear you well.
Thank you. And yes, we could imagine fully electrical eVTOLs flying on batteries, for example, which will have one solution. If we talk about medium range aircrafts, you could look into aircrafts which are powered by fuel cells and hydrogen. If you then go to the long range aircraft, you would again need a different solution. And I believe that the engines with SAF, for example, will have a very important role to play to bridge the time until we get to more disruptive solutions. And we can then imagine there have a direct hydrogen burn, for example. So I don't see it as a competition. I think there are different elements to the answer to decarbonize the industry, and depending on what type of product you're looking at, you will be developing or using a different set of technologies to answer the questions of decarbonization.
Yeah, thanks for that input. I have one last question before we do a final round. The question is related to the overall emissions. We're always speaking about CO2, and CO2 has a very long-lasting effect. It stays in the atmosphere for 100 years or longer, and then we have shorter-term effects coming from NOx or contrails. Question to Pawel, how do you see those effects? Because I've seen very different numbers coming from very different institutes on global warming potential for those different elements, CO2, NOx, and contrails. How do you see that? What is your perspective on that topic? You are muted.
Okay, thank you for the question, Axel. Different opinion, and they are quite radically different. Some people say that the overall impact of aviation is huge, and in my opinion is negligible, but it's visible. Coming back to the core of the question, that's right. Majority of research nowadays is dedicated to decrease CO2 emission, but chemical combustion process is very specific. If you rise temperature, you have more NOx, and you create problems somewhere else. My personal opinion is that we should be smart optimizing combustion to eliminate, let's say, CO2, keeping in mind all the others that can be exhausted together with the trust we generate. And I share the opinion of people who spoke before me that we should go into different technology depending on the different application and different market, right? If we will try to go for hydrogen, for instance, or for fully electric aircraft in long-range planes, then we may create more issues connected to these warming gases than we expect. So we need to be smart. We need to be listen to universities like Cranfield University, which is one of the best in my opinion. And we should remember about the balance. We shouldn't focus only on one CO2, or only on one NOx or other gases. How to do it is a long story, and I don't think we can find an answer during this short meeting here.
Unfortunately not, and unfortunately also we have to come to an end. The time is nearly over. I'd like to use the last couple of minutes to ask each of you one simple question, and if each of you maybe within 30 seconds can respond to that question. And the question is, what is from your point of view the most important element on the way to climate neutrality by 2050? What is the most important element? It can be a technical element, it can be a cooperation element, it can be whatever. So starting then with Henrik, what is from you within 30 seconds the most important element towards climate neutral aviation?
Well, this is clearly the time to act with joint forces to make a step change towards zero emission of flight. We believe that sustainable aviation will be met through collaborative work, challenging targets, and with safety as the number one on the agenda. So GKN is definitely committed to be an integral part of that journey. So collaboration is my answer.
Thank you, Henrik. The next one, Iain, what is your view?
Well, I would reinforce Henrik's position about collaboration. It's about working together. It's about airlines, airports, aircraft manufacturers, universities, regulators all working together. But I also think it's very important we get the policymakers to really understand the size of the challenge and the role they need to play in terms of investing both money and on regulation itself. So the role of policymakers, I think, is really important.
Thank you, Iain. Then María, over to you. Can you hear me?
Yes. If I can,
what is your view?
Yes. If I can add something else, yes. A part of the technical topics that we have been talking about, hydrogen, more electrical aircraft, and new materials. I think that it's really important to define and to implement aligned strategies in Europe. So it's very important as well to reduce, to simplify the procedures, the bureaucracy, the administrative parts, aspects, and of course we have to collaborate. We have to integrate the big, small companies, academia, universities, everything. So we can do it all together. So thank you, Axel.
Thank you, María. Now over to you, Luca. You had a bit of time to think about. On the other hand, a couple of points have been mentioned already. Anything else from your side? What do you think?
Okay, so I can just echo the point about collaboration, which is key. I will just elaborate more around that, stating that we need to be very focused on what are the most impactful solutions, because it's true that we have multiple options on the table. There is not a single one option, one solution, but we need to be very focused on prioritize our effort because we have limited capacity.
Thank you, Luca. And now, Pawel, what is your view?
Well, a lot of already having been said. So collaboration is number one, which I was trying to show on my slides. Regardless the future scenarios, collaboration is a key and common goal to everybody. But second key is to be strict. Money. We need to support the goal. I mean, the way we go with appropriate amount of funding, because technical capability is there. If collaboration is there, the only thing that we may be missing is, I believe, appropriate funding to support our ideas, to make them real.
Thanks, Pawel. And last but not least, Sandra, your view on that?
Thank you. So to come up with something different compared to what has already been said, I would say the pioneering spirit. Yes, we need collaboration with our classical partners, but more than ever, we need to look at cross-industry collaboration. And for that, we need an open mind, we need a pioneering spirit, we need to envisage different solutions to the way we have used them up to now. And this is, for me, really what is going to make the future of aerospace. So encourage the young ones and keep the pioneering spirit really high.
Thanks, Sandra. So let me now use the last minute we have to try to summarize. I think what I have heard today is that climate neutral aviation by 2050 is possible. So I think that was shared by all of the panel members. I think we are in front of a huge challenge. And I think what I also understood is that one of our first and foremost challenges is a change in thinking. It needs to start there. We need to start thinking about revolutionary technologies. We need to start thinking beyond evolution. We need to start pushing the envelope. And this cannot wait. We can't wait until the year 35, 40. We need to start now working on those gains and need to develop those technologies which are necessary before the end of this decade. And I mean developing up to a very solid tier of 6, so that those aircraft developments which are following the technology development will have a good baseline for the work. Furthermore, what I heard as well is that we need to think about sustainable, preferably zero carbon fuels, and that work needs to go hand in hand between the technology development itself and the sustainable aviation fuels. We have heard points around liquid hydrogen. So that's also a very important point, I think, which has been crystallized out over the last weeks and months, that it's not about sustainable aviation fuels as drop-in alone. We are going beyond. We are going into non-drop-in liquid hydrogen fuels, which need to be in the focus of all of us in the near-term future. I mean, in terms of technology development, in terms of application, it will take a bit longer. I think what we also need to keep in mind that it's also about flight routings. It's also about optimizing the flight envelopes. It's about air traffic management overall. And I think we can't accept the political unwillingness, which I see out there, to resolve issues which we see in the single European sky. I think that's an element which we need to take into account as well. And then please also let me indicate two topics which I think needs to be looked at. I think that's looking at going beyond the current convention. We are in certain cases, and I don't mean you because you have highlighted a couple of points today, but I think we need to also look at the over-standardization, which I may call it, in the current development and design of aircraft. So do we need aircraft which are designed around lower than 3,000 kilometers? At the moment, we are designing aircraft which are able to do everything between 500 and 5,000 kilometers. Should we not rather focus our efforts on aircraft which are geared and focused on lower than 3,000 kilometers range? The same question around speed. At the moment, there's a huge flexibility in speed. Should we not also reduce the speed and by that reduce the emissions which we see there? I think those elements that request a change in thinking and will impact the whole society in terms of the research community, the development community, the air traffic management, but also the airport community. What comes out very clearly from all of you is we need an aligned approach of all stakeholders. No one alone can do that, and there is also no silver bullet. We need a synchronized roadmap of all those people, all those entities, and that makes it not easy. But I think I share that with you. It's absolutely vital. And finally, and that was also said by some of you, we need an effective regulation framework around the topic, and we need appropriate financial framework as well. I think we talked about that. This approach is quite a high-risk approach, high gain, but also high risk, and that needs to be also supported by public financial incentives for research, but potentially also in the next step for the deployment. I think we have made great efforts during the last years and decades even. Clean Sky 2 and the results of Clean Sky 2 are definitely a part of it, but we need to change gear. We need to think out of the box, and we need to align all the forces in order to make climate neutrality by 2050 happen. I'd like to thank all of the panelists very much for your contribution today. I'm very much looking forward to continue working with you, moving forward towards that target, and I would like to thank obviously also our audience for your contribution, for your participation, for your questions, and for your attendance. Thanks a lot, and have a good evening and late afternoon. Thank you, and bye-bye. Hope to see you soon.
Thank you, Axel, and I still see in the stream, congratulations for the session, Axel. That was somebody who stayed with the session the whole time and was actually listening from the first minute to the last minute, which was the 90th minute. And with that, we can actually look back at the day and look forward to tomorrow, the 26th.
Yes, Connie, I think it was an inspiring day for sure, with a lot of information, a lot of impressions. And when I look back at this day, I just have two things in my mind. The first thing in the morning session already, we heard it from Grazia Vittadini. She said, nobody can manage the challenge alone. And we heard this statement. Sometimes this day, also at the last panel, at the last minutes. So cooperation is a main topic. And the second one, my favorite sentence from this day comes from Ivo Boscarol. He said during a panel, without dreaming, there's no process. So it's a congress of scientists and engineers, but a congress of poets also. I did like that very much.
I'm quite amazed, actually, at some of the beautiful language being associated with the industry that we've heard throughout the days. And yes, ladies and gentlemen, we really do come to an end. It's been a long day on the first day of the forum. The second day is just around the corner with 3 major sessions. Digital solutions for automated air traffic management. We already touched upon that yesterday. We're going to look at something that's around the corner, that's almost happening and it's taken off in the true sense of the word, urban aviation. And then we're going to look at the future as such.
Yes, the last panel will be visions of future aviation. This is the main topic in all these days here, but then in the last panel it will focus again, and we're very much looking forward to this. So, Connie, I think for today,
That was it.
That was it.
Enjoy your evening wherever you are and keep up the green energy.
Enjoy. See you.